Hello everyone, and welcome back to my channel. Today we will be solving IMO 1984 Problem 1. And the problem states, let x, y, z be non-negative real numbers with x plus y plus z equal to 1. Show that 0 is less than or equal to xy plus yz plus xz minus 2xyz is less than or equal to 7/27. So I'll go ahead and box this inequality. And now your first thoughts may be to use AMGM or Cauchy-Schwarz, something that we can use to prove that this expression is indeed valid. However, in this solution, I will be doing something a little bit different. Notice that this expression has a lot of symmetric sums, which we can exploit. So we will start by defining a polynomial, piece of t, which has the roots x, y, and z. So piece of t is equal to t minus x times t minus y times t minus z. And this may seem a little strange at first, but as we go through, you'll see why it makes sense. And it also is just to take advantage of the symmetric sums that we have. So, upon expansion by Vieta, this becomes t cubed minus x plus y plus z times t squared plus xy plus yz plus xz times t minus xyz. And we know that x plus y plus z, this is equal to 1. So our expression becomes t cubed minus t squared plus xy plus yz plus xz times t minus xyz. Now, if we plug in t is equal to 1/2, something interesting happens. We get piece of 1/2 is equal to 1/2 cubed, that's just 1/8, minus 1/2 squared, which is 1/4, plus half of xy plus yz plus xz minus xyz. And this simplifies to negative 1/8, the 1/8 minus 1/4, plus 1/2 of xy plus yz plus xz. And we can actually take the minus xyz and bring it into the parentheses like so. And this is our starting expression. This is our expression of interest, and we've just expressed it in terms of piece of 1/2. So in our original problem statement, we wish to show that this expression is bounded by 0 and 7/27. So if we plug each of those values here, we'll get that negative 1/8 is less than or equal to piece of 1/2 is less than or equal to 1/216. And this we really just get by plugging in 0 and 7/27 into the expression. Now this is the same thing as negative 1/8 being less than or equal to 1/2 minus x times 1/2 minus y times 1/2 minus z less than or equal to 1/216. And now we will proceed with casework on each of these terms being positive or negative. So our first case is that x, y, and z are all between 0 and 1/2. This would mean that each of these terms, 1/2 minus x, 1/2 minus y, 1/2 minus z, each of them is positive, in which case we can apply AMGM inequality. So we get that the cubic root of 1/2 minus x times 1/2 minus y times 1/2 minus z, this is less than or equal to the average of each of those values, so it's their sum divided by 3. And we know that x plus y plus z is equal to 1. So this is 3/2 minus 2/2. So on the top we get 1/2. 1/2 over 3. This is just 1/6. Now we can cube both sides of the inequality and get 1/2 minus x times 1/2 minus y times 1/2 minus z is less than or equal to 1/6 cubed, which is just 1 over 216. And that completes the first case. Now the second case is that one of these terms is negative. So if one of those terms is negative, we won't be able to use the AMGM inequality on all three. So without loss of generality, we're going to assume that x is greater than 1/2. In this case, 1/2 minus x will be greater than or equal to negative 1/2. Because if x is greater than 1/2, we know that x is bounded by 1/2 and 1. So we get the following expression. But anyway, let's consider what happens when we apply AMGM on 1/2 minus y times 1/2 minus x. By AMGM, this is less than or equal to the sum, which is 1 minus y plus z over 2. This is just x over 2. So if we square both sides of the inequality, we get 1/2 minus y times 1/2 minus z is less than or equal to x squared over 4. Sorry, this should be a z. Okay. Well, x is bounded, has an upper bound of 1. This is less than or equal to 1/4. And 1/2 minus x is greater than or equal to negative 1/2, which means piece of 1/2 that's equal to 1/2 minus x times 1/2 minus y times 1/2 minus z. This is greater than or equal to negative 1/8, and it's also less than or equal to 0. And that completes it. We were able to show that piece of 1/2 is between negative 1/8 and 1 over 216, and so we are done. Thank you so much for watching, guys. If you enjoyed this video, feel free to subscribe to my channel and stay tuned for more proofs.